are all doing great. How things going on? Guys, I'm audible?
Yes, you are.
Yes,
Yeah.
yes, you
How are
are.
you doing, guys?
Good. How are you?
Yeah, I'm doing great. Thanks for asking. Yeah, let's recap that earlier session. In a couple of minutes, we'll close it, and I will jump into the another topic, which is going to be excited for today. Yeah, as discussed on last in the last class, that what is the cloud, why the cloud is needed, and what is the flavors of the cloud, and how the functionality will work in the cloud. We discussed in the first class. Okay, as discussed, as informed, if we want to have the any kind of implementation of the software, we need hardware and networking and software engineer and maintenance. These are all required to cloud. It doesn't need any kind of hardware configuration. Hardware configuration not required. Hardware configuration is not required, and network configuration is not required. Network engineer also not required. Network SE is not required. And coming to that, maintenance, that is not our headache. That would be taken care by service provider, who is called, like in the market, we are having 3 cloud platforms, right? Azure, Microsoft by Microsoft, and AWS by Amazon, GCP by Google. Their headache of the maintenance. And we observed, we discussed in the last class about how how the data will be stored in the cloud environment. As informed you earlier, that it will perform, it will follow 3 replication factor, which is like in the backend also, it will follow the Hadoop architecture. As informed you earlier, if you are loading any kind of 5 MB or else any kind of one file into the cloud storage, it will take, it will in the backend, it will be stored as a 3 replications, which is in one CPU, it will be stored at one point, and later on it will be moved and it will follow the replication factor as a 3. And every cloud environment, and if you see the white papers which was released by the Amazon or else a Microsoft or else the GCP, where this about the structure, what is the algorithms they are following in the backend, is all about to the Hadoop architecture will be followed by the all the service providers, all the cloud service providers. Okay, and coming to that, why exactly Hadoop is needed here? That is a question next. Why? What exactly the challenges? What is the benefits we are going with the Hadoop architecture? Hadoop architecture is a compatible hardware. Means like it is commodity hardware, can be used in the backend. Means it is an open source software. Like commodity hardware is nothing but it is kind of a cheap hardware. Not cheap means not much cheaper. Like cheap in the sense it is in the perspective of hardware. It will use commodity hardware. And why commodity hardware is using? You might get a question. We are having our sensitive data, we are storing it in our cloud and we are using. If the commodity hardware is nothing but a cheap hardware, where is case of all the I can say you like if you are having HP storage, it will be cast type comparing to the Sonata. The Sonata will be a commodity hardware. Why this all the backend architecture is using the commodity hardware? That will be a question. We are storing our interesting and our confidential data into the cloud storage. If we lost, there might be chances, there might be crashes with the cheap data. That might be any question arise in your mind, right? So when coming to pardon, can go on mute. Anyone? I think Raj. Oh, perfect, perfect. Okay, so why the commodity hardware will give the specific uh, boost up our cloud architecture means it will follow the three replication factor in the backend. If you are storing one file here, and it will follow the replication in another node, it will follow another replication in another factor. Okay, in the back end, if you are uploading any kind of a 5 MB file or 10 MB file, or whatever the size it is, it will follow the three replication factor in the cluster level, in the racks, and in the nodes. It will follow the three replication factor. Then once this file was gone down, for example, let's say it got deleted, or else it is unresponsive. Let's say immediately my resource manager in the Hadoop architecture, it will speak with secondary node, the second node. What is the status of your? It will be called as heartbeat mechanism. Every 3 seconds or every 5 seconds, it will be based on the configuration in the cluster level. For every 3 seconds and every five seconds, it will create a log whether this node 1 is active or not, as node 2 is active or not, node 3 is active or not. If the node 1 is down, immediately it will reach to the node 2 and it will speak, hey node 2, give me my data. Is this existing with you or not? It will check in from the node 2. If the node 2 also down in the bad and worse scenario, it will come into here, node 3. In the scenario here also we lost the data, then how can we get the backup? That is an wondering, right? So here is the concept called redundancy in the Azure, in the cluster level. Redundancy is nothing but, for example, here we are having here, for example, let's assume that here this is in the all over the world we are having Asia region. Okay, Asia region and East US region, Europe region, and Australia region, and Chinese region. Chinese also comes under Asia, right? Which is not required. So in these regions, according to the requirement, according to the number of users who are using their service, the service providers will create the clusters in that particular region, and they start giving the access to the users from that particular uh, region. For example, let's say US is an a big country, right? There is a many number of users in the US. We are having East US, East US, East West US, West US region cluster, and South Central US. In this South Central US cluster, these are all the cluster varieties. For example, let's say I was opted. There is a three kind of redundancies the Azure will follow. Let me give you a clarity. Okay, there is a three redundancies. One is redundancy, okay, and geo redundancy, geo zonal redundancy, and geo redundancy. Okay, local redundancy is nothing but here, as we discussed here, this is one cluster. Okay, for let's say this is existing in the Southeast Asia. Okay, this is existing in the Asia region. Okay, Asia region. Okay, for time being, let's assume that this is US. Okay, for example, here we are having, as I informed, local redundancy and zonal redundancy and geo redundancy. Okay, if you are opted for this Asia region, if my three this one was gone, okay, three data nodes was gone, then you are unable to get your data when you are opting for the local redundancy. And local redundancy is nothing but you are only the people who are residing in the Asia region. Okay, they can access the data, who are having the access permissions to that. Okay, coming to the East US data, East US, if you are having the zonal, okay, in that, for example, as I informed you here East US, West US, and South Central US, right? It will, you have to opt the zonal level. What is the zone is required, and availability of, for example, here you are having the 3 replication factor in the Asia region. If your Asia region was down, you can get the backup from the East US. That is called another backup for your data. Another 3 replication factor will be followed in the backend from the East US region. Where coming to the geo redundancy, all over the clusters where it is existing and where it is residing, all clusters will hold your data, and you can, if one cluster is down, immediately you can get from other cluster. That is called geo redundancy. This is the features of the cloud service providers. Getting? So these are all the differences between local, zonal, and geo redundancy. And most of the companies, most of the Fortune 500 companies will go for zonal redundancy. Why they can't go for the geo redundancy means it is a cost effective. On the basis of your usage in the clusters and cloud, they will charge. That is the income for the service providers. This is the motto. And in the back end, okay, we are done with that, right? As we discussed here in the here, what exactly the architecture it will look like, how the service providers like Microsoft and Amazon and Google are there landing their clusters, and we are unable to, how we have to interact with them. That is the next question to ask, right? So usually any of the service provider, they will give one URL and one link to the users to use their services. For example, if we consider that for Azure we are having portal.azure.com, portal.azure.com. For AWS there is aws.in. In GCP there is another site like that. They will give the one user interface link to their users, and with that they can able to access their services. This is the array. Yeah. So this is the main UI of the Microsoft Azure. Here we can create the resources and virtual machines. I have to log out for this. This is my office one now. Okay. So these are all the resources are existing in the Azure. By searching here, we can get all the resources. Storage accounts. If you go, you can create one resource and you can get that one. That exactly what is needed. Let's go. So with that URL UI, we can access the services by using the interface. Internet is a medium between you and the cloud service provider. It might be an Azure, it might be an AWS, it might be a GCP, Google Cloud Platform. Okay. In that, once you was entered, as I was shown to you over there, you have to opt what exactly the resources are needed. With that, let me sign in into this. Allow me a second, guys. Bear with me. Tabbing the password is not coming. So once you was entered into your once you was logged in into your cloud service provider, for example, let's consider that Azure. Once you was logged in, you have to create your subscription And once you was created your subscription, under that you have to create your resource group. Resource group is nothing but like we are having the folders, right? In our laptop, C drive, D drive will hold the folder. In that we will create one folder as a resource group. Inside that we will attach what exactly our requirement is needed. For example, we need our one SQL database. This will go over there, will type and search. As I was searched for the Azure storage account, right? As similar to that, we will search for the SQL server. Then it will give you the SQL servers list. Which version of SQL server is required over there. Then you have to opt and you can install that, and you can while you are configuring the SQL server, it will show for the payment and usage, and what is the amount is going to be charged for this particular usage, particular resource. Okay, according to that we will opt and configure as per our requirement. Okay, which compare to your local demonstration, which is called, which you was called here in this, which is very very lesser than our own configuration. Just you are creating, you are using and destroying. That is the main feature of any cloud platform. Okay, once we are done with that, then you are start implementing your logic and your project build as per according to the work requirement. Later on, if you want any kind of the security and the management, as I earlier said, that is not your headache. That would be taken care by the cloud partners like Azure, Microsoft, and Amazon and GCP. That is not your headache. Maintenance, management, and security, that is not your headache. They will be taken care. But internally, for example, let's say you in your organization you are having 100 members, 100 people in your organization, right? So each and every person wanted to access your data. Then how you are going to provide the security to your data? Means in that in your project also there is project manager will be there. In on top of project manager, another technical project manager will be there, another PTA will be there, and business partners will be there. And later on, under your project manager, your technical lead will come, and under the technical lead you will be the employee, right? Under your technical advisor you will be an employee, right? So they will manage, user to user, role based assignments, role based permissions they will give. So for example, I am having one storage account is nothing but one space. We are opting one space for particular folder. Okay, folder or name, just we are creating one folder. Later on we are dumping the data into the storage account. It's kind of an hard disk. We are just buying the storage. Okay, in that in that they will give you the role based assignments to access the particular file. If you are not in if you are not having an access to that particular storage account, you can't able to access the data which is existing inside that. That is called security. Inside the internal application security, that is called. Okay, coming to the management is nothing but you are having you are doing your work each and every day. Okay, and your colleagues will do their work, and your technical lead will do another work, your technical advisor will do another work, right? To collaborative way to collaborative way to collect all the works of the employee, and reporting it to the project manager, and delivering it to the our clients. That is called management inside that. Okay, that is an internal management and security. By using the Git repository and CI/CD, there is called concept called Azure DevOps. Using that, they will collect all the data, but with the artifacts, they will collect all the data, they will dump into the management, and they will deliver it to the clients. Okay, this is the entire cloud infrastructure, cloud architecture in the from the back end, how it will work. Okay. Coming to that, flavors of the cloud. One is in Microsoft Azure, another Amazon AWS, as I said, GCP, Google Cloud Platform. Okay. What is the differences we are having? That is a big question to us, right? Okay. So these are all the functional and behavioral differences between AWS, Azure, and GCP. Okay. App testing. It uses device form, AWS. It uses the dev test labels. Okay. This is not required, just for your general awareness, to have the general glance on the different cloud platforms I'm explaining you. But in the real time environment, this is theoretical knowledge is completely dumb. That is not required. Whatever you are having in hands on, whatever you will implement your pipeline, how you are building the pipelines, that is a plays a key role in the interview and in your work. This is the general sake of knowledge. That is I can say. Okay. That API management can be done Amazon API gateway and Azure API gateway and cloud endpoint. This is GCP4. Okay. And coming to this one Kubernetes management. Okay. That is EKS. This is all called back-end functional activities. Okay. For example, if you write any kind of a Java program, okay, it will in the backend it will be converted as bytes, right? So this is all the behavior from the backend. Okay. And Git repositories, AWS, this one, Amazon source repositories. Like we are having the two flavors here. Coming to the Git, one is a Git repository, and another one is a DevOps from Amazon, this Azure. Okay. Data warehouse, Redshift, it will use SQL warehouse. Okay. Object storage, S3. Object storage is nothing but the storage account. As I said, it will use relational DBs, which will be in the backend of the storage account. It will be used. This one, blobs and files. That is nothing but, this is nothing but Azure data lake, I can say. Okay. And this is called Google Cloud Storage Account. That is.
What is Azure source repositories?
Pardon?
Azure source repositories.
Like as I said earlier, we are having 10 members in our team, right? Okay. To collect all the data. Okay. To collect all the employees' data by using Azure DevOps and Git repository. They will collect by using the CI/CD pipeline, by implementing CI/CD pipeline. For example, if you did some modification to one of the a prod environment issue, usually we will have multiple environments in our in ADF or else any resource, right? So if you did any kind of an there is an chance of getting a mistake, or there is a kind of an in the prod, it is an highly secured one, right? So to get the backup, to get the resource, restore the data to the previous version, they will use Azure DevOps. And CI/CD is a flow by using the artifacts. They will pick and it will be used.
Yeah, I mean, like when you are comparing Git repositories with AWS and Azure has its own Azure repos, right? As a service.
Yes. Azure DevOps is a own service, but it will support for Get repo as well.
Yeah, it supports.
Yeah. It clarified, right?
Yes.
Yeah. Coming to the relational, these are all the back-end things which are not required for your interview purpose, and which is not required for you will not get to know each and every aspect in your real-time environment as well. But in the backend, in the cluster level, how it is functioning, that is the point. This is an object storage. Object storage is a S3 bucket, and this is the S3 bucket is nothing but it is just a collection. It will support for the Oracle and it will support for the SQL, whatever it is. Just you can collect the data into the Amazon S3, and by using the any cloud service provider to service. For example, I would like to give you one example here that I'm holding my data in Amazon S3 bucket. I would like to use it from Azure data factory. That would be possible. There is kind of an we can create one bridge for the one cloud partner to another cloud partner. Later on, we can perform the flow of transformations. Okay. And coming to this blocks storage is an EBS and a page blobs and personal disks. Okay, I will share it with you guys. Kindly go through each and everything. I will explain you on that part if you find any difficulty. So main thing, what exactly the roles and responsibilities of an Azure data engineer or Azure data factory engineer, Azure Synapse Analytics engineer. First point, when you are entering the organization, you should have the GANs and must and should migration part from on-premise to the cloud or cloud to cloud or within the cloud, within one cloud. You should have the knowledge on the migration part. Migration is the major role will play in cloud environment. Why I'm specifying the migration is the main backbone of usage of the cloud is migration is to avoid the creation of the our on-premise servers and on-premise environments. On-premise is nothing but local. Despite of that, instantly we are purchasing from the cloud, we are using it. So previously, before to the COVID, most of the projects are existing in the on-premise machines. So once the COVID was gone, it was gone like it was difficult to maintain the servers and difficult to access the data. If difficult to manage the servers is getting into the more risk. To avoid all the glitches, most of the Fortune 500 companies are using our Azure as a cloud service, and they are migrate. There are so many projects wherein in the year of 2018 to 2020, I can say. Okay, migration is nothing but just lift and shift. I can say lifting the data from the our local existing data to the cloud environment. That is a major role. And coming to the pipeline buildings and maintenance, according to the logic, for example, according to the logic, you have to able to build your pipeline with using the different activities and different transformations and different schedulers. According to that, you have to run your pipelines and transforming the data. Main concept of the Azure Data Factory and Azure Synapse Analytics is kind of ETL and ELT operations we can do. ETL and ELT is nothing but extract, transform, and load, extract, load, and transform. ELT, extract, load, and transform. Okay. ETL is nothing but extracting the data from on-premise and transforming the data and loading into our cloud environment. Okay. Main difference between ELT is nothing but extracting the data, first up, pulling the data from the on-premise servers and loading it into our cloud environment. Later on, as per our requirement, you have to transform by using your ETL tool called ADF and Synapse. Okay, there is one difference between by using the ADF and Synapse. One cloud service can't provide two ETLs. This is an analytical tool. Okay, we'll discuss on this. It is a very big topic about the differences between the ADF and Synapse. We'll discuss on that part. Okay, so you should have the glance on this one. Main roles and responsibilities should be have your ETL and ELT knowledge on that. Okay, transforming data by using the data flows and by using the pipeline activities as per your requirement. You have to do that, and by using the analyzed data. Analyzed data is nothing but we will not deal in the real time with 1 or 2 or max to 10. No, max to 10. No, I can say we will deal with TBs of data. TBs of data. And sometimes it may lead to one pipeline with the high configuration. It might take around 5 hours to load from on-premise to the cloud environment. I can surely say. So you are capable to take the challenges on according to the need. Why I am saying that? Analyze the data means without having the glance on that particular on-premise data. For example, I am having the on-prem SQL server. On-prem SQL server. Okay. On-prem SQL server means since from 2000, my client is using on-prem SQL server. Okay. He is having around 20 TB of data. Okay. So directly dumping the 20 TB of data into the cloud, which will cost huge billing. Okay. So there might be chances. There is a chances, not might. There is a chances we can reduce our data into the 15 TB or 10 TB. There might be a duplicates, removing the duplicates and analyzing the data and removing the duplicates and shortening and encrypting the data and only opting the required fields. This kind of transformations we have to do. To do that, we have to firstly analyzing capability, and we should have the analyzing capability of the data. What is the format we are getting from the source, and what exactly it is existing in our sink side. Our sink is nothing but destination. I can say here in the Azure terminology, we'll use it as a sink. Okay, and yeah, maintaining the deployments. When coming to that, this, for example, for our 10 TB or 20 TB of the data, our timeline is 5 months. Oh no, not 5 months. 5 months is more enough. 2 months. Let's consider to migrate from on-premise to the cloud to perform the migration. Okay. Maintaining the deployments. There is, if I do the entire 20 TB of data, my all pipelines will go on. All pipelines will be in stack. Why? It is a huge amount of data, and there might be chances of the duplicates, and there is kind of an throughput. Throughput is nothing but speed of transformation. Speed of transformation might be cause the issue. There might be an n number of statuses. So initially, what I'll do is from the 2000 to 2005, I'll segregate the data. I will load it into my cloud environment. Initial load. Okay. Later on, 2002 to 2005 to I will take 2010. Okay. That is called incremental data. Until I will finish my data, I will load into my destination sink. Okay. Once it was done, so it will take around 2 months of data, right? 2 months of time. In these 2 months also, the data will be generated, and which will store it in on-prem SQL. that also important to me, right? To run that one, I will use, finally, once I'm done with that, I will use dry run. Once I was fixed that in every organization, I hope you was observed the maintenance time. In the maintenance time, will perform the dry run, and later on completely will do the all deployment into the cloud environment. Okay. Building logic according to your scenario. For example, let's say in this scenario, you are having around, let's assume that we are having per pipeline around 30 transformations, which will lead multiple, which is needed multiple kind of changes in the data. Why we are using this transformations here is the major aspect, the major point why we have to use the transformations here is to reduce the cost and to reduce the reduce the balance in the sync side, and to improve the performance of the throughput and improve the application usage. For example, we are having any kind of reporting tool, let's say BI tool, let's say Power BI tool is there existing. Okay, for that team, our data is existing in different cloud platforms and different on-premise multiple resources. Okay, the major role here comes to collect the data from the other resources, and we have to perform some kind of transformations over there. So we can't perform the transformations in the Power BI. Okay, I hope you didn't got this point. Building a logic according to our scenario. What is needed for 2016 to 2016 and 2023. Okay, let's assume. Okay, we are having 2016 data in on-premise, 2016 data in on-premise, 2023 data in cloud. First, I have to load this on-prem data into cloud where my 2023 data is existing. Data is existing. Okay, once I was done with that, once I'm done with my at one point I am having the data, then my 2016 data is holding 150 columns. Okay, 2023 data is holding around 280 columns, from which I just need for, let's say, 40 columns in both, where the match is existing with the serial number or else customer ID or else any kind of trans ID. Okay, so this is the logical building. This is called a logical building according to the scenario. Okay, and structuring the pipelines using different activities in the data factory, I will explain you clearly in when we are building the pipelines on this. Coding as per your project need. For example, if you are working on a SQL server, you should have the just familiar with your SQL queries, simple queries. Okay, and If it is for other kind of a Python project or kind of any kind of project, you should have a little glance on that. That is enough, more enough for that. But to learn the Azure Data Factory, as per my insights, no coding is required. Just having the sample glance on the Azure SQL queries like select transformation, select queries, and store procedures are more enough to learn that one. Okay, these are all the responsibilities, and these are all the real-time scenarios which you are going to face once you are stepped into organization. Okay, from tomorrow we'll start logging into our Azure portal, and we'll create one new subscription into that, and inside that we'll create the resources, and we'll step further, step by step. This is all the theoretical part before we are stepping into the cloud environment. Okay, we'll next jump into our practical examples. We'll play with data and we'll play with Azure in the real environment. And I would like to get into your notice, guys. My style of saying, mostly I will tell in this way, and later on I will just give you the overview of the scenario. For example, we are having one storage account, how we have to create, and what exactly is needed to that. I will explain how the data is stored in the backend. I will tell you here, and later on I will jump directly into the real-time scenarios. I believe if you are having a more hands-on your practice, then your mind also will addict to habituate. It will automatically habituate to that particular content. I believe in that. So my style of saying is this one. If you are having any questions, guys, feel free to, you can ask. Sandeep, over to you. Sandeep, I'm audible?
Yes, Krishna.
Yeah. This is about today. If you have any doubts, you can ask me.